This will be a brief demonstration of the function of the brake motors we used on our bandsaws here at Forrest Manufacturing. If you've watched any of my other videos, you've heard me talk about how we use a motor with an integrated brake on our bandsaws to stop the blade. The idea being that when you stop, you've been making cuts, the saw's been running, when you make the machine stop, you hit the stop button, we want the blade to stop just about instantly. On most bandsaws, if you hit the stop button, the motor will stop, but it will coast, and the blade will take some time to spin down. So the operator will have hit the stop button, they'll be thinking the machine is stopped, they'll reach past the blade to maybe grab their workpiece, potentially cut off their finger or something bad. We don't want that. I like to build our machines with a brake integrated in the motor, such that when you hit the stop button, the blade stops just about instantly. What you're looking at here is the brake on the back of the motor. The motor's here, the gold thing's the motor. Bolted on the back is a brake. We use mostly Bandaws motors. Bandaws buys their brake assemblies from a company called Stearns, basically bolted to the back of the motor. So first I'm going to give you a real-time demonstration, then I'll give you the slow walkthrough of what is happening and what the potential adjustments are, and then I'll show it to you again at full speed once you have maybe a better understanding of what's happening. So I'm going to start the saw up, the brake will release, and you'll see the motor spinning. You can see the shaft sticking out the back, spinning. I hit stop, and it stops pretty much instantly. So what's happening here? This brake is a spring apply magnetic release brake. So you've got two springs, one here, one on the back side, that squeeze the brake pieces together. So you've got a series of plates, steel plate, friction disc, steel plate, friction disc, steel plate, stacked together. The steel plates are hooked to the shaft, the friction discs are hooked to the motor frame, so when you squeeze them together, it causes the motor to stop. Basically, if you're at all familiar with like a motorcycle clutch, the same basic idea. But by squeezing those plates together, it causes the motor to stop. These springs are the pressure that causes it to grab and stop. To release the brake, this uses an electromagnet. This black piece right here is an electromagnet, also called the coil. Whenever electric power is applied to the motor, it is also applied to this electromagnetic coil. The coil energizes, and then here we have a part we call a plunger. When the electromagnet engages, it pulls the steel plunger in. That is what is releasing the brake. So you can see, as I push this down, these parts release just a little bit, just enough that I can then spin the shaft. When I release, can't spin the shaft. If you're wondering why the shaft is sticking out the back end, that is where the fan bolts on, the fan that you use to cool the motor. So what can happen here? Like I said, in normal operation, the spring squeezes the plates together and lifts this coil up. When we energize the magnet, this part pulls down into the magnet and releases the shaft so it'll spin freely. This brake uses friction material, just like your car brake uses friction material, and eventually it will wear out. So the spring will be pushing it closer together, but eventually there's not enough friction material to grab. Then even though the springs are trying to push, there's just not enough friction material. There is the potential for adjustment here. Can't see it readily from this angle, but there is a plastic card right here that shows the adjustment positions. So you're reading the height of the underside of this T-bar to this adjustment piece. And if you have any questions, ask me and I'll email you a copy of the service instructions for this. Makes it more clear. But what happens is, if this is popping up too far, what they call the air gap is too large, you're not going to grab the brake. You can adjust that by turning some of the screws. There's little screws right here. You can't see them very well. You can adjust that and it will adjust the initial position of this plunger. So if your machine is not stopping properly and this T-shaped plunger is riding very high, then it's probably just the case you need to adjust your brakes. Contact me, I'll send you the instructions, you can adjust your brake and go about it. Eventually those plates will wear out completely, you'll need to replace them. There are other failure modes though. This electromagnetic coil can burn out. Either too much or too little voltage can cause the coil to burn out. Very often when this happens, this coil swells up and the plunger will either get stuck in there or it won't be able to pull in and the brake won't release. So if this coil can be replaced, again, call me if you need to talk about that. But the coil will burn out and either you won't be able to get the plunger in or the plunger won't come out. That's a failed coil. That's pretty much the only two things that can go wrong with this, is replacing or adjusting the plates or replacing the coil. So now that I've given you the talk through, I'll turn it on automatically one more time and then we'll be done. So starting up the motor, stopping again. Starting up the motor. So if you have any questions about this part of the bandsaw or anything about our industrial bandsaws, please feel free to call or email us here at Forrest Manufacturing. Thank you for your time.